All right, so something that I have learned is that my ProDrafts calculator does not do what it is meant to do. So I really need to use the Apple calculator for most of these. So the first one is relatively straightforward, 0.0093 ln. So we round it to 2 decimal places to the hundredths. That's going to be negative. Let me get my pencil here. That's the only problem with using the Apple computer or calculator is it goes away. So negative 4.68. And this is just the cursor. It does not have an impact on your answer. All right, then when we do the next one, and I'm going to be upfront, I struggle with logarithms. I know that they're easy when I'm in the middle of them, like when I've taught the lesson, made the video, gone over it. They're fairly easy to understand. They're just exponents, but I haven't seen them in a couple years, and so I would really have to dig into them and spend some time studying them to be fluent in them again. You know what I mean, right? It's like a different language to me. So for now, I'm just going to walk you through how to get the answer, right? Which buttons to press instead of trying to explain how they're solved. Reality, you might have one, maybe two of these on the ACT. So if you miss those two and nothing else, that's pretty darn good. Okay? Don't struggle. Don't pull your hair out if you can't figure them out. All right, just move on. All right, for this, it's going to be the same thing. You type in the number, you press the ln key, you hit the equal sign, 4.14. All right, this one's a little bit different. Basically, this is just going to be that. Let me get you there. So you would type in 5163 and then ln ex and equal 5163. So this would be the exponent on the e. That's all you're doing. All right, so this is, I think it's the log 10 button, 2.136. I think that's, let me double check. Okay, I had the wrong button. You're going to type in 2.136 and hit the 10x key. And that gets you there. So when you have log of x, it is the 10x key. So for this key, it was the ln key. You type in the number and then you do the ln key. Same thing here, number and the ln key. For this one, you type in the number and then the ln key and then the e to the x key. And that gives you the exponent that goes on the e. For this one, whenever it says log of x, you type in the number and then you type in the log 10 key. Okay. And that's going to give you this number here. I round it to two places, 136.77. 136.77. All right, let's go to the next one. All right, we're going to use the ln key to express each number as a power, and then use the rules of exponents to find the answer. All right, so basically you're going to take ln in front of these and multiply times each of these, right? That's basically all you're going to do, but you got to use a good calculator to do it, or you can go to Google and just type in ln parenthesis. So if you don't have access to a really good scientific calculator, you can always do it there. So let me show you this first one. You can see where I've done some of this before. So ln, and then that is 0.123612, and hit enter. And it's going to give you the answer. I'm going to round that to two places. So it's going to be e to the negative 7.40. So we go back here, e to the negative 7.40. That's what the ln key does. It gives us that exponent for e. So now we're going to do e here for 576. And you can just go back and you can take this out and put 576 in here and hit enter. 6.36 would be your answer. So you don't have to go nuts over this. What did I say? 6.36. 6.36, right? And then the same thing here. You can just type it in on your thing here, and I'm going to type in what is it? It is 0.0512 times 10 to the negative 14th power. And this little hood button right here, that means to the power. And it put it in the calculator just like I typed it. So if we round this, it's going to be negative 35.21. That's what you want to do. Just use Google. Just honest to goodness, use Google. That'll give you the right answer. Negative 35.21. So e to the negative 35.21. And then we just use our rules for exponents to find the answer, like it says. So we know what to do here, and we can use this calculator right here. It's not going to steer us wrong. So we've got 6.36 is positive and 7.4 is negative. So that's going to be e to the negative 1.04 over e to the negative 35.21. We know when we bring this to the top, this could be a positive 35.21. So we can add 35.21 and we end up with e to the 34.17. That's the answer we're looking for to this problem. Okay, so you just express it as an exponent and then combine your exponents just like you normally would. Next problem. Again, you're going to want to just use your, your Google, right? So x is equal to, well, for this one, we can use the calculator. That won't be hard. We know how to do that. So again, it's just the number and the ln. So 0.0052 ln negative 5.26 is what that rounds. So negative 5.26. Here, we're going to do the ln ex key. Let me pull that calculator back up. So clear 51.5, and I think we do ln, and that's it. You just do the ln key here. So that's going to be rounded 3.94. So 3.94. So again, ln key, the number, and the ln key, the number, and the ln key. Same thing. When you have this negative 4.16 here, you're going to have to use like the inverse key, or you can just type it into Google. ln x equals 4.16. I'm just going to do that. ln x equals negative 4.16. Enter. All right, so it's going to give me my solution. Show all the steps. So my answer here is going to be this, and we want to put it in scientific notation because it's decimals. So it'd be 1.56 times 10, 1, 2 backwards to the negative 2. So that's going to be my solution. 1.56 times, that's a 5. Let me erase that. 1.56 times 10 to the negative 2. Just type it in Google. It'll be all right. Same thing, only now we have a log here, and we'll type it in Google. So this will become log, and it gives you solution at the bottom. You can see the steps of how it solves it. It's approximately 6.918. We're going to round that to 2 spaces. So 6.92 times 10 to the negative 5. 6.92 times 10 to the negative 5. These are not, hills you have to die on. These logarithms are not. Like I said, unless you're going into math, statistics, and data analysis, and things like that, things that require, a science, a math-heavy science, right? You're not going to need these for real life. It's okay if you don't know how to do them for yourself. You might need to keep them fresh for your children one day, right? And their math problems, but you can always Google it. You can always Google these. When you don't understand the answer, just type the whole thing in. I don't have a problem with that when it comes to logarithms, because the logic is solving the problem yourself, you can't. You need to use a calculator to do it. So in my mind, if you got to use a calculator to do the whole problem for you, what is the difference in using Google to do the whole problem for you? Right? Okay. That's my perspective. Miss Anna might disagree, so ask her. But if you've got to use the calculator to do the whole problem, why not use let your calculator be Google? If it is a problem where there's mental math, don't do that. Actually do the work. So this one, we break this down where we unsquare each part of the fraction. That's not an equal sign, is it? That's a minus. And we'll turn that into a fraction too, just for funsies. All right, so now we're going to solve. So that'd be 2 square root of 3. We know we can't leave this as a square root of 3, so we're going to multiply times square root of 3 over square root of 3. And then that would be 2 times square root of 3 over 3, right? This can be resolved. 2 times square root of 3 over 2, which would bring that down here. 2 times square root of 3 over 2. And in this, I know is going to be 3 times 16. So that is going to be minus 3 times 16 times 3 over 1. This can be pulled out and made into a 4. So it's be minus 12 times the square root of 3 over 1. All right, now that we've reduced everything and conjugated and made everything in the right format, now we need to find a common denominator. So it's going to be 6. So this would make this 6. That would make this 6. And this would make this 6. So that's going to be 4 times square root of 3 over 6 plus 6 times square root of 3 over 6 minus 72 times the square root of 3 over 6. And this 4 plus 6 is 10 minus 72 is going to be 62 times the square root of 3 over 6. So when I reduce this, that's going to be, this is only divisible by 2, so that's going to be 31 times the square root of 3 over 3. That's going to be your final answer. All right, next problem. So we've got x plus 2y, x minus 3z, y plus 2z. When you have a situation like this where you don't have anything in common between them, you can create a third equation, or a fourth equation. We have 3 equations. So this is A, this is B, this is C, and I'm going to make D. All right, so D, we have 2 x's, so 2x. I have plus 2y plus another y, so plus 3y. I have a negative 3z and a positive 2, so it's minus z is equal to, these two cancel each other out. That's 10. All right, so notice here that d is equal to 10 and x plus 2y is equal to 10. So that means these two are equal to each other. So I can say x plus 2y is equal to 2x plus 3y minus z. So I'm going to subtract 2x from both sides. I'm going to subtract 2y from both sides. So these cancel and these cancel. So I've got negative x is equal to y minus z. We know we don't want negative x, so we multiply everything by negative 1. So E, my new equation here, is going to be x is equal to negative, instead of saying negative y plus z, I'm just going to say z minus y. That just reverses that. All right, so now I have a value for x that I can put into either of these, right? That would help me then compare here. So that's what I'm going to do. I'm going to take A and I'm going to substitute in E. So that's going to be for x. That's going to be z minus y plus 2y is equal to 10. So that means z plus y is equal to 10. So that means that z is equal to 10 minus y. All right, so that's another equation, another substitution that I can find. I can also use B, and I can create x minus 3z. So that's going to be z minus y minus 3z is equal to negative 16. So z, that's going to be a negative y minus 2z is equal to negative 16. Negative 2z is equal to negative 16 plus y. So that's going to be I can put in the value of z here, negative 2, 10 minus y, so I can solve for y, finally. Negative 20 plus 2y is equal to negative 16 plus y. So minus y plus 20 plus 20, y is equal to 4, because this cancels and this cancels. So now that I have a value for y, I can find the value for z, because z is equal to 10 minus y, which is 4, so z is equal to 6. Now that I have a value for z and y, x is equal to 6 minus, and y is 4, which equals 2. So my values here are 2, 4, and 6. X is 2, y is 4, z is 6. So sometimes you just have to keep combining, creating substitution values, using logic to go from one to the other, right? Use your logic until you can narrow it down, till you can get to a value. Then you can start subbing that value back in to all the other things, like solving for z. Once I got y, this was easy. Once I got y and z, x was easy. But I had to get there, right? I had to create those substitution values to get there. So it might be a little bit of a process, but you can do it. You just got to think it through. So that is the correct answer. All right, here we've got 1.2 repeating 1, 3. I'm going to show that it's a rational number. We're writing it as a fraction. Quotient of integers, just a fraction. So I'm going to take this number, and I'm looking at the number of places that are repeating. So I'm going to use that many zeros. N is equal to 1.213 with the 1, 3 repeating. So 100, there's 2 places. So 100 times this number, 100 times n, is equal to moving the decimal place back 2 spaces. So that's going to be 121.3, but then the 13 is still going to repeat. 13, 13, 13, dot, 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 on and on and on, right? It's a repeating 13. I'm going to take this same number and I'm going to multiply it by a -1, which is going to make this number -1.2 with a repeating 13, 13, 13, dot, 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 right? So now that's a negative number, we are subtracting all of this excess baggage. We get rid of the repetend in that way. Now we can just subtract these values. So 121.3 minus 1.2. That's going to be 120.1, and 100 minus 1 is 99n. So n is equal to 120.1 divided by 99. But we don't want a decimal inside of a fraction. That's a fraction in a fraction that's very complicated. So we're going to multiply in order to get rid of the decimal value. So however many places, that's how many zeros you use. 10 over 10. So n is equal to 1,201 over 990. And I'm not sure which way I have it typed in Jupyter. It'll either be like this or with a comma. And I may have actually gone back and put both options in. If it doesn't take it like this, try it with a comma. You might get lucky whichever way you type it in first, it takes it. Or I might already have them both in there. All right, so there were 35 nickels, dimes, and quarters in all, and their value was $5. How many coins of each type were there if there were 2 times as many quarters as nickels? All right, so nickels plus dimes plus quarters equals 35. And their value is 5 times nickels plus 10 times dimes plus 25 times quarters is equal to 500. And 2 times as many quarters as nickels. So quarters is equal to 2 times the number of nickels. Okay, so there's my original equations. I'm going to use this to substitute into both of these to create a smaller equation, something with only 2 variables. So n plus d plus 2n is equal to 35. So 3n plus d is equal to 35. Okay. 5n plus 10d plus 25 times 2n is equal to 500. So 5n plus 10d plus 50n is equal to 500. So 10d plus 55n is equal to 500. Okay, so what I'm going to do is I'm going to multiply this. Let's call this A. We'll call this B. I'm going to multiply A times -10, right? So -10 times A is going to equal -30D minus 10. Oh, I did not look at that well, did I? So D is first, so let's write D first. -10 times D would be -10D. That's what I'm trying to do, is cancel these out. And -10 times 3n is a -30n. And -10 times 35 is going to equal a -350. So this would cancel. This would be 25n is equal to 500 minus 350 is 150. Right? Divide by both sides by 25. N is going to be equal to 6. All right, so there are 6 nickels. Now, number of quarters is 2n. So 2 times 6 equals 12. So the number of quarters is 12. So I can say the number of dimes plus the number of quarters, it's going to be 6 plus 12. That's 18. So 18 plus the number of dimes is 35. So dimes is equal to 35 minus 18, which is 17. So there you go. So all we did was we created our 3 equations. We found a substitution for Q. We went ahead and put Q, and then we made these much easier. We hammered these down to 2 equations with nickels and dimes only in there. Then we were able to multiply so we could get an elimination value that would cancel. And then we divided and found the number of nickels, which then made it easy to find quarters, which then made it easy to find dimes. All right, that's all we did. Next one. All right, remember, when you're doing these, this is really just this. Right? It's this 3 times. So if you get confused on these, you can just write it out 3 times or however many, or just remember what it looks like, right? Remember that it is this 3 times. So then once you write it out like that, you can go, oh, well, duh. It's 3 times 3 times 3. Basically, it's 3 to the 3rd power. Then you have x, and then 3 times 1 to be 3 to the 4th power. 3 times 1 is 3. Y, 3 over 2. And then this is a 1. 3 times m. 3 times 1 is m. Or if the 3 times 1 is 3, it would be m to the 3. Then all you have to do is simplify this. So 3 times 3 times 3, that's 27. X, 3 over 4. Y, 3 over 2. M to the 3rd power. This is your solution. And that's as far as you can go because we don't know the value of any of the variables yet. Okay? So just remind yourself, this just means this. So if I were to multiply 3 times 3 times 3, I get 27. And x to the 1/4 times x to the 1/4 times x to the 1/4, we're just adding them together. So there's 3 of those. Same thing for the y's. There's 3 of those, so there's 3 halves. And then there's m to the 1, m to the 1, m to the 1. There's 3 of those. We add them together. That's m to the 3. And I think that's your last question. Yeah, it is. I don't see more here. That's the last one. So when it comes to the logarithms, just Google them. Use the Google calculator. It has more spaces and more calculating capacity than the typical Apple, although Apple is probably comes in a close second. A digital calculator is going to give you more places, more place value than your standard solar power or battery power calculator. So you might come to a better solution using Google. And the benefit of Google is if you don't remember exactly the process, it will show you and refresh your memory. So, like I said, when you're doing the entire process on the calculator, you're not using any mental math to solve it. I don't have a problem with you using Google to do that because that's just your calculator. Okay? That's all I have for now. I will see you in the next lesson or video or class. Bye for now.